Welcome back, class 10th. We had started with the optional exercise from third chapter, exercise 3.7 on page number 68 in the NCERT textbook. Today we shall be doing a few more questions from the same exercise. Let's take a look at the first question. The ages of two friends, Ani and Biju, differ by 3 years. Ani's father Dharam is twice as old as Ani and Biju is twice as old as his sister Kathy. The ages of Kathy and Dharam differ by 30 years. Find the ages of Ani and Biju. So, just for convenience, let us say that Ani is represented by A, Biju is represented by B, Kathy by C, and Dharam by D. These are not your variables. I am just using the letters to avoid using their names. Since we need to find out the ages of Ani and Biju, we need to represent the ages of A and B by two variables. So let us assume A's age as X years and B's age as Y years. Now in the first case they have given that Ani and Biju, their ages differ by 3 years, means the difference in the ages of these two is 3 years, but we don't know who is elder. It is possible that A is elder, Ani is elder, or Biju, B is elder. So there are two possibilities. If Ani is elder, Ani means A is elder, then the difference in the ages will be given by the age of the elder person minus the age of the younger one equals to 3. The difference in the ages is 3. This is the first equation. The same condition can also be written in this way. If Biju is elder, this is the other way around, the other possibility for the first condition. If Biju is elder, then the age of Biju will be more minus the age of Ani, the younger one, equals to 3. This is your second equation. You will be taking only one of these two at a time. Then second case, in the second case they are saying the ages of Dharam and Kathy differ by 30 years. Now for that we need to first of all know what are the ages of Dharam and Kathy. So let's see what they are saying. They are saying Dharam is twice as old as Ani. So Dharam equals to 2 into A is X years old. So the age of Dharam is 2x years. And they are saying that Biju is twice as old as Kathy. So Biju's age has been represented by Y. This is equal to 2 into C. We have not any variable to represent the age of Kathy, so I'm writing it as C. From here, Kathy's age comes out to be Y by 2. Take a look. We already have assumed the ages of Ani and Biju as X and Y. Using X and Y, we are going to write down the ages for Dharam and Kathy. The relation between the ages of Dharam and Ani and the ages of Biju and Kathy is given. Dharam's age is 2 times the age of Ani. Ani's age is X, so Dharam's age will be 2x. On the other hand, Biju's age is twice the age of Kathy, so Biju's age Y equals to 2 into Kathy's age. So from here, Kathy's age comes out to be Y by 2 years. According to question, the ages of these two people differ by 30 years, means the difference of these two ages is 30. Now in this case, there are not two possibilities, there's just one possibility. Since Dharam is the father and Kathy is the sister of Biju, father will be elder, so the elder person's age minus the younger person's age, the difference is 30 years. Let's simplify, take LCM. Taking the LCM for these two terms, simplifying, This becomes 4x minus y. Transposing this 2 to right hand side, it will be multiplied with 30. This becomes 60. So this is the third equation. Now what you have to do is, since from the first condition you had two equations formed, but you are supposed to take only one at a time. So either you will be taking one or you will be taking the second equation with the third equation and you will obtain the answers. So you have to solve two pairs. One pair is equation 1 and 3 and other pair is equation number 2 and 3. So you will be solving these two. So equation number 1 from here is x minus y equals to 3. Equation number 3 is 4x minus y equals to 60. Now this can simply be solved by elimination. Let's subtract, changing the signs. This is minus 3x equals to minus 57. Negatives cancelled, x comes out to be 19. So this means Ani's age is 19 years. To find out Biju's age, I am using equation 1. Put x equals to 19 in 1. So 19 minus y equals to 3. 19 minus 3 equals to y. Transposing these two to opposite sides, minus 3 taken to the right, 3 brought to left hand side. So y comes out to be 16. So Biju's age is 16 years. Now you can see that the two friends, the age difference is 3 years. Let's solve the second case, equation number 2 and equation number 3. Now equation number 2 is when Biju is elder. So we have y minus x equals to 3. Let's take the third equation. Third equation is 4x minus y equals to 60. This is the third equation, 4x minus y equals to 60. So I'm writing it over here. 4x positive minus y, arranging, equals to 60. Eliminating y, let's add. So this becomes 3x equals to 63. X comes out to be 21. So that means Ani's age is 21 years. Put x equals to 21 in 2 now. We are not using 1 this time. We are using equation number 2 and equation number 3. So don't make the mistake of using this in the first equation. Over here we are just using second and the third one. So I'm putting x equals to 21 in second equation, which is y minus x, which is 21, equals to 3. So y comes out to be 24. So Biju's age comes out to be 24 years. You have to solve both the cases. Continuing further from the same exercise, we have already done second question. Now we will take up third question. A train covered a certain distance at uniform speed. If the train would have been 10 kilometers per hour faster, it would have taken 2 hours less than the scheduled time. And if the train was slower by 10 kilometers per hour, it would have taken 3 hours more than the scheduled time. Find the distance covered by the train. Now, they have described two situations in which the train could cover the distance. And the changes are being done in speed. So if the speed changes, time taken also changes. But the distance remains the same. The distance to be covered remains the same. This is what we will use to form the pair of linear equations. We will change the speed and time, and we will make the equation keeping in mind the fact that the distance covered in either case is the same as the original one. So let's start by assuming that the original speed of train and the original time taken by the train as x and y. So let speed of train be x kilometers per hour the time taken be y hours. So if the train is moving with the speed of x kilometers per hour for y hours, then the distance covered will be given by speed into time, which is x into y kilometers. This is the distance which the train is covering. First case, if the speed is increased, so the new speed is increased by 10 kilometers per hour, and the new time will be reduced by 2. If the speed is increased, time taken will be less. But the distance covered should be same as the original one. So distance, which is given by speed into time, speed is x plus 10 multiplied with y minus 2. This should be equal to this distance. Distance remains same. There's no change in the distance covered. The train is covering the same distance. The speed was increased, so the time got reduced, but the distance remains same. So the distance with these speed and time should be equal to the distance obtained originally. Let's simplify. Solve this product using distributive property. So you get xy minus 2x plus 10y minus 20 equals to xy. Xy will get cancelled. You are left with this, the simplified form. All three terms are multiples of 2. Let's take 2 common. This can be transposed to right hand side, and on simplification the equation that you get is minus x plus 5y equals to 10. This is your first equation. Now in the second case, again there is a change to the speed and the time taken. The new speed in second case is a decreased one. In the second case they are saying the speed is reduced by 10 kilometers per hour. So originally the speed was x, reducing it by 10, new speed. And in that case, when the speed is reduced, the time taken will be more. The time is 3 hours more than the original time. Originally y hours were taken, so increased time is y plus 3 hours, and according to this the distance is equal to the product of speed and time, which is x minus 10 into y plus 3, and this should be equal to x into y. The distance still remains the same. Let's simplify. This becomes xy plus 3x minus 10y minus 30 equals to xy. Xy will get cancelled, so 3x minus 10y equals to 30 is your second equation. So you shall be solving these two equations and find out the value of x and y. After solving, x comes out to be 50. X is representing the speed. Y comes out to be 12. Y is representing the time taken. But the answer is the distance covered. The distance is given by speed into time. This is the speed. This is the time. So total distance covered is the product of these two, which is 600 kilometers. Okay, now we will do question number 4 from exercise 3.7. Let's take a look. The students of a class are made to stand in rows. If 3 students are extra in a row, there would be 1 row less. If 3 students are less in a row, there would be 2 rows more. Find the number of students in the class. So imagine the students of a class being arranged in rows. Let's take an example on our own. If, for example, your class is made to stand in rows, if one row has 6 students and there are 8 rows. So what can you say about the number of students? So there are 8 rows, means there are 8 lines. In every line there is 6 students standing. Can you tell me how many students will be there? It will be 6 into 8, which is 48 students. So this is the concept we shall use for this question. If we know how many rows are there and what is the number of students in one row, we can tell how many students are actually standing in the arrangement. So let's start by assuming how many rows were originally made and how many students were made to stand in every row. So let's say let the number of students in one row be x and the number of rows equals to y. Then the number of students who are standing in this arrangement with y lines and x students in every line, it will be given by the product of these two, which will be xy. So there are a total of xy students in the class. In the first case, they have changed the arrangement. They have increased the number of students in each row. Since they increase the number of students in each row, the number of rows will reduce. So let us consider the same arrangement. Earlier I said there are 6 students in every line. So what if one row has 8 students? What I did was, there were 6 students, I increased the number of students by 2. Now in every line 8 students are standing. Can you tell me how many rows would be there? So I have to arrange 48 students in such a way that every row has 8 students. The number of rows will be 6 and still the students are 48. So 6 lines, 8 students in every row, 48 students arranged. In first case, the number of students in every row has been increased. Earlier there were x students, they have increased it by 3. Now the number of students in one row is x plus 3. But the number of rows has reduced by 1. Earlier there were y rows, now there is 1 row less, y minus 1. But the number of students still would be same. The number of students will be same as the original number of students. And to calculate the number of students, what we do is we multiply these two. So the number of students in one row multiplied with the number of rows, this should be equal to xy. The number of students remains the same. Simplify. Xy minus x plus 3y minus 3 equals to xy. Xy will get cancelled. You can transpose it to left hand side. It will get cancelled with this product xy. You will be left with minus x plus 3y equals to 3. This is equation number 1. Let's consider the second case. In the second case, they are decreasing the number of students in each row. Now, if from the original arrangement, from the same arrangement over here, when I made 6 students stand in one row and I made 8 lines, the number of students was 48. Let's decrease this. Let's decrease the number of students. Now, one row, we have 4 students. Earlier there were 6 students in one line. Now I have decreased the number of students. So to arrange 48 students, how many rows would I need? I would need 12 rows. Again, the students are 48. 12 lines. In every line there are 4 students. So the number of students is 48. This is what is happening in second case. The number of students in one row has been reduced. Initially, in the beginning, there were x students in every line. Now they have decreased it by 3. Because of that, the number of rows increased, and the number of rows increased by 2. But the number of students is still the same in the arrangement. So the number of students will be given by the product of these two, x minus 3 into y plus 2. This is same as the original number of students. Let's simplify. Xy plus 2x minus 3y minus 6 equals to xy. Again, the product xy will get cancelled. You will be left with 2x minus 3y equals to 6. This is equation number 2. Now you will be solving these two equations. Solve number 1 and number 2. Once you solve these two equations, you will be able to obtain x and y. So x comes out to be 9, y comes out to be 4. So x tells you the number of students in one row, and this tells you how many rows are there. There are 4 rows, and every row has 9 students. So the number of students in the arrangement will be equal to the product of these two. 4 into 9, which is 36. There are 36 students in the class.